Okay, so here's our approach. We're going to start out by assuming the null hypothesis is true. And then we're going to go out to the actual population, collect a random sample, and compute a sample mean. We're going to ask ourselves the question, assuming the null hypothesis is true, right? Assuming we guess the right population mean, what is the probability of getting the sample mean we actually collected? In other words, how likely is it, if the null hypothesis is true, how likely is it that we get a sample mean like the one that we actually collected from the real world? In a sense, this probability, which we're going to call a p-value, tells us, is our sample supporting the null hypothesis? So how do we interpret the p-value? Well, if the p-value is small, if it's very unlikely that the null hypothesis is true and we end up getting a sample mean like the one we collected, then this is evidence against our null hypothesis. And if the probability is very small, then we can start to think of that as giving evidence that's beyond a reasonable doubt. That's so unlikely that I have no doubt in my mind that null hypothesis can't be true. Typically, we set a threshold as researchers, what we want to consider a small enough probability to think about quantifying this idea of reasonable doubt. So oftentimes 5% is used as the threshold. If your p-value is less than 5%, then that's good enough to say that the sample provides evidence beyond a reasonable doubt against that null hypothesis. So our fundamental question here, after getting a sample, finding this p-value is going to be, is the p-value below that small enough threshold? Now, in research, oftentimes you might want to be a little bit more rigorous or a little bit less rigorous, so it's often common to pick your own what we call significance level. So this can be 1%, this can be 10%, it kind of depends on the discipline and how certain you need to be in certain situations. The symbol that we end up using for significance level is alpha, and this is the same value or the same quantity that we kind of looked at when we were dealing with confidence intervals as well. So we're going to ask, is the p-value less than alpha? That's going to be our final question. If it is, then we'll say that we've hit this beyond a reasonable doubt threshold. Here's our general process. We're going to take a claim, write out the null hypothesis and the alternative hypothesis. Using our sample data, we'll compute a sample mean. So this is information we get from the actual population. Again, we don't get to see the whole population, but we can take a snippet of it. We can take a sneak peek by looking at sample data. We're going to compute a sample mean. In step 3, we're going to determine the probability that the sample mean we collected, or something more extreme, actually occurs under the assumption that our null hypothesis is true, right? Using this null distribution, we'll be able to compute an actual probability there. And I'll talk a little bit in more detail in our heuristic example about how you compute a probability like that. Based on the results, we're going to choose from two possible conclusions. If our p-value is less than our significance level, p-value less than alpha, this essentially means it's very, very unlikely, beyond a reasonable doubt unlikely, to get a sample mean like ours with the null hypothesis being true. So our conclusion is that we're going to reject our null hypothesis. We have evidence to reject the null hypothesis. If, on the other hand, our p-value is more than our significance level, we haven't quite proved beyond a reasonable doubt that the null hypothesis is false. In other words, the sample mean we collected, even if it's a little bit unusual, it's not so unusual that we're convinced beyond a reasonable doubt that the null hypothesis is false. Okay, so these are the two possible conclusions, and they all depend on comparing this thing, well, the p-value, against our significance level. Now, in this particular course, we're going to have 3 different types of null and alternative hypothesis pairs. So I'm just going to go over those quickly before we do a heuristic example that'll give us more information on step 3. How do we compute this p-value based on an observed sample mean? Okay, so let's do some quick examples of setting our two hypotheses. One thing to keep in mind in traditional statistics textbooks, the null hypothesis is going to be associated with the claim that uses an equality, right? So if you're, For example, the mean expense for a sales dinner is $1,300 or less. Inside of this claim is the possibility that it's equal to $1,300. So this claim itself, the mean expense, which is our mu, is less than or equal to 1,300. We're going to associate that to our null hypothesis. And then the alternative hypothesis is just going to be the opposite conclusion, right? Well, if we're not less than or equal to 1,300, we must be greater than 1,300. This is going to be a very special type of test. We're eventually going to call this a right-tailed test for reasons that you'll see once we start drawing pictures. But this is the basic setup. Here's our next example. The average score on a statistics exam is 76 or more. So pause the video here and write out your null and alternative hypotheses and see if you get the same answer as I do. Remember, the null hypothesis is the claim that has the equality. The alternative should be the one that is a strict inequality. All right, let's see. So our claim here is that the average score, again, this is talking about a mean, is 76 or more, so this would have the equality piece. 76 is an equality piece or more. So we're looking at mu is greater than or equal to 76 for our null hypothesis. Our alternative is going to be a strict inequality, and this will be a less than. We'll come to call this a left-tailed test when we start working with these in more detail. All right, last example. The mean amount of time a person spends listening to music each week is 12.7 hours. Again, pause the video, write out your null and alternative hypotheses. Remember, this is step one in our process, so you have to make sure that you're comfortable with this initial step. All right, so again, remember the null hypothesis is the one that includes some sort of equality, so we're looking at the time equaling 12.7. So that's our null hypothesis. Mu equals exactly 12.7. Our alternative is what we call sort of a two-sided alternative. All we can say here is, well, if the claim is that we're equal, the opposite of that would be not equaling, right? So mu is not equal to 12.7. And there's two ways that this could happen. You could have a mean that's bigger, or you could have a mean that's smaller. And so we're eventually going to call this thing a two-tailed test to account for those two different ways that you could have an not equals in your alternative hypothesis claim. Moving back to our general process, once we've written out the null and alternative hypotheses, our next step is to use our sample data and compute an actual sample mean. And now what we want to elucidate next is this item number 3. Determine the probability of observing our sample mean under the assumption that the null hypothesis is true. How do we do this? Let's consider a heuristic example.